here we go. We're going to start talking about this. The perimeter of a rectangle is 30 centimeters. The width of the rectangle is 3 more than 1/2 its length. What are the dimensions of the rectangle? Okay, so the very first thing that I'm going to do is I'm going to draw a rectangle to try to help my brain get an idea of what's going on here. So I'm going to draw my rectangle. Okay, so there's my rectangle right there. And it says, I'm told, the perimeter of a rectangle is 30 centimeters. So my perimeter, and perimeter means the distance around the rectangle. So I'm going to add up all the sides of the rectangle, and that's how I'm going to get the perimeter. So my perimeter is 30 centimeters. Okay? Now, the formula for the perimeter is 2L plus 2W equals perimeter. And we get that because this is my length and this is my width. Okay? So if this side is L, this side has to be L. If this side is W, this side has to be W. So you don't necessarily have to have the perimeter memorized, but that's the formula. Now, I will give you the formulas that you need for your test. So it's 2L plus 2W equals P. But here we're told the width of the rectangle is 3 more than 1/2 its length. So what I would do is I would focus on this right here. 3 more than. How do I write 3
plus?
I would write 3 more than as plus 3. Okay? Plus 3. Okay? How do I write 1/2 its length?
1/2.
1/2 L. Excellent. 1/2 L. Okay? So my width right here is going to be 1/2 L plus 3. So determining what the algebraic expression is for the width is the challenging part of this problem, okay? But once I am able to identify that, then I just plug it in. So what I'm going to do is I'm going to take this 1/2 L plus 3, and I'm going to plug it in for that W right there, okay? So now I've got 2L plus 2 times 1/2 L plus 3. And that equals my 30. So this is the formula that I'm using right here. I get my 30 from right here because it tells me the perimeter of a rectangle is 30. My 2L stays the same because I get that from this L right here. Then my W, I replace that W with this right here. 1/2 L plus 3. Okay? Getting the equation is the difficult part. Any questions on how I got that? Any questions how I got to 2L plus 2 times 1/2 L plus 3? Are we good? Okay. Now what we do is we solve the problem. So I have 2 times L. Okay. Then I've got to distribute this 2 right here. So what is 2 times 1/2?
1.
It's 1, okay? So then I've got 1L plus 6. Now I'm going to go right here. So I have 2 over 1 times 1 over 2L. That's what's happening when right here. Okay, so I'm distributing the 2 to the 1/2 L. So my 2's cancel. I'm left with 1 over 1, which is 1L. So now 2L plus 1L is 3L. 3L plus 6 equals 30. My next step, I subtract 6 from both sides. I'm left with 3L equals 24. So L is what? I heard it. 8. Very good. L is 8. Okay, so L is 8 centimeters. Now, how do I know it's centimeters? Good. Excellent. It has centimeters in the problem. Now that I know that L is 8 centimeters, I can go back to 1/2 L plus 3. So now I'm going to do 1/2 times 8 plus 3. That's going to give me my width. What is 1/2 of 8? Good. So then I've got 4 plus 3. So what's my width? 7 centimeters. Okay? Okay. Bradley bought a pair of shoes on sale for $120. If the discount was 20%, what was the original price of the shoes? Okay? So, you've got to identify $120 as how much he paid for the shoes. And remember, his shoes were on sale. Okay? They were on sale. So we are looking for a price that is more than $120 because $120 is how much the sale price was. So, this is where sometimes students get confused. If the discount, this is how much he got off. The discount was 20%. Okay? What percent did he pay of the original price? Okay, so we're not looking for the original price. Okay, we are looking for the original price, but right now, I want to find out what percent of the original price did he pay, because the discount was 20%. Okay, so the discount was 20%, so what percent did he pay for? That's right. Good job. Everybody's whispering like, is that the right answer? Yes. So you've got to subtract the percent discount from 100. And if you can remember to do that, you're probably going to get the problem right. Okay? Students forget to subtract that discounted price from 100. Okay? So we get that. So 100% minus the discount gives us the 80% of the original price that he paid. So he's paying 80%. Now, the next thing that I have to do is I need to write 80% as a decimal. How do I write 80% as a decimal? Say that one more time.
Move the decimal to the left.
How many times? 2. Good. So 80% becomes 0.80, but I want you to realize that 0.8 and 0.80 are the same thing. So anytime that you've got to go from a percent to a decimal, you're going to move 2 places to the right. Percent always means out of 100. That's what percent means. Just by definition, it's out of 100. So now I have 80% or 0.8 of the original price is my sale price. Now, do I know what my sale price is? How much did Bradley pay for the shoes? $120. So $120 is my sale price. Okay, so my sale price is $120. Okay? Typically, what does of mean? What operation does of mean? I heard it. Multiply. So of means multiply. Okay? Do we know what the original price is? Do we know what that is? No, that's what we're figuring out. So then I put this into a formula. 0.8 times x equals 120. So I'm going to divide both sides by 0.8, and that's how I'm going to get my price. So let's remember, can I erase the stuff in red on the right, the discount 20%? Can I erase all that? Okay. So now I want to remind you how to divide decimals. Okay, so this is something that will be helpful. Okay. 120 goes in the box. 120 goes inside the box. The 0.8 goes on the outside. Okay, I can't have the 0.8 on the outside. I've got to make it without a decimal. So I'm going to move this decimal one spot. Okay? If I move the decimal there one spot, what do I have to do with the 120? Move it one spot. Okay?
No, you're good. I was just going to try to unlock that.
Okay. So we actually are dividing now, since we moved the decimals over, we're going to have 8 going into 1,200. Okay? Now, 8 will not go into the 1. So you can put a little mark over the 1 if you need to. Then we say 8 goes into 12 one time. 1 times 8 is 8. I subtract. Then I brought down my 0. 8 goes into 40 5 times. 5 times 8 is 40. Okay, then I bring down my 0 again. Okay, so how much was my original pair of shoes? $150. Now, sometimes you might have to keep going. Not in this situation, but sometimes you might have to keep going. So my decimal is right there, and I might have to bring up that decimal. Okay? This time we didn't. Okay, we got $150.00. But it's possible that you might have to go in and determine how many cents it is. So I just want you to be aware that when you're dividing, you just pull that decimal straight up. Okay? Maddie has an 86, 84, 90, and 91 on 4 of her math tests. What does she need on her 5th test to get an A, and an A is defined as a 90 or above, in the class? So the first thing that I want us to think about, there's 4 tests. There's 86, there's an 84, a 90, and a 91. Okay, 4 tests. If we wanted to determine what Maddie's average was right now, not including the 5th test, her average right now, what would I do with the 86, the 84, the 90, and the 91? Add them up and then divide by, why 4? Because there's 4 tests, okay? And I've got all 4 tests up here, okay? So if I wanted to know what Maddie's grade in the class was right now, I would add all these up and I would divide by 4. But that's not what I want to know. I want to know what happens after the next test. So I am going to add an additional test right here, plus x. Okay? Now how many tests do I have? 5. So I've got to divide by 5. Now, I don't want her grade to just equal a 90. What do I want?
It's like an equal, like greater or less.
Yes. Is it greater than or is it less than?
You want it to be greater than or equal to 90?
Exactly. I want it to be greater than or equal to 90. That's what I want. Okay, so that's why I use that inequality. 90 is okay, but so is a 91 or a 92 or a 93. Okay? So, now the way that I solve this is I am going to add up all of my tests. So I have an 86. I have an 86, an 84, a 90, and a 91. I'm going to add up those. And remember, we're not using a calculator, so you want to be sure you're adding those up without a calculator. 6 plus 4 is 10, plus 1 more is 11. Okay? 1 plus 8 is 9, plus 8 more is 17, plus 9 more is 26, plus 9 more is 35. Okay? So the sum of these numbers right here is 351. But I haven't dealt with the x yet. So I have 351 plus x. Okay? Now, one of the things that I've seen a lot is students will take that 351 plus x and somehow in this next step they turn it into 351 times x. Okay? But that's not it. This right here is plus x. And they almost always have it right here, but after they add everything up, they change it. So be aware of that. Now, in order to get rid of that 5 at the bottom, you're going to think about how I solve 2 equals x over 3. How do I get rid of that 3 in the bottom? Good. I multiply both sides by 3. And then I'm left with x equals 6. That is the same process that I'm using over here. Okay? I multiply everything times 5 over 1. These cancel.
Well, actually, I just multiplied the 5 to each side.
Okay, and that's what we do. We multiply both sides by 5. So then I have 351 plus x is greater than or equal to 450. Now, if you need to think about how to do that multiplication, this is what that multiplication looks like. I have 90 times 5. 5 times 0 is 0. 5 times 9 is 450. Okay? Then my next step is minus 351. So, x is greater than or equal to what?
91.
It is, it's not 91. It's 99.
99. Oh.
99. Okay, so.
I did it again.
Okay, so we have 450 minus 99. So let's remember how to borrow. You can't say 0 minus 9. So I've got to mark out my 5. I turn it into a 4. My 0 becomes 10. 10 minus 9 is 1. I've got to do it again. 14 minus 9 minus 5. No, where did I mess up? Oh, okay. Forget what I just did right there. It's 450 minus 351. I was subtracting 99, which is our answer. Okay? We can't say 0 minus 1, so I've got to change the 5 to a 4, turn it into 10. So 10 minus 1 is 9. Okay? I've got to change my 4 to a 3 and change it to a 14. 14 minus 5 is 9. 3 minus 3 is 0. So my final answer here is 99. So Maddie needs a 99 or higher. Okay? Okay? Now sometimes you've got to read this 2 or 3 times to really get your mind on what's happening. So 2 airplanes leave Birmingham. Okay? So here's Birmingham. Okay, we got a plane going this way and we got a plane going that way. 2 airplanes leave Birmingham going in opposite directions. The eastbound plane travels 50 miles per hour faster than the westbound plane. Okay? So this one is traveling 50 miles per hour faster. Okay? Do we know what the westbound plane is traveling? We don't. If it takes 3 hours for the planes to be 2,250 miles apart, what is the rate or speed of each plane? Okay? So, ultimately, here are the distance between the 2 planes. There's the distance. What is that distance? What's the distance between the 2 planes? 2,250 miles. Okay? So they have traveled together, 2,250 miles. Okay? And how long did it take them to travel that long? 3 hours. Okay? So they traveled this amount of time. This plane traveled 3 hours, and this plane traveled 3 hours. Okay? We know the total distance, and we know the time that each plane traveled. Do we know the rate of the westbound plane? Can we identify that as R? Can we say that the westbound train or plane is traveling R miles per hour? I know. I guess I want to go on a train. Okay? Can I say that this one is R right here? Okay? Can I say that? So if the one going westbound is R, what's the one going eastbound? Based on this right here. The eastbound plane travels 50 miles per hour faster.
Distance equals rate times time.
It does, and we are going to use that. We are going to use distance equals rate times time. But how do I represent my eastbound train? Okay. The eastbound plane travels 50 miles per hour faster than the westbound plane. My westbound plane is traveling R miles per hour. So how fast is my eastbound train traveling? What do I have to add to 50?
2,200.
That's my distance. Say that again? T. It's actually not going to be represented as T because we know our time is 3 hours. So we know that our time is 3 hours right here. So the eastbound plane travels 50 miles per hour faster. Here is R. How do I represent 50 miles per hour faster than R? R plus 50. R plus 50. And that is sometimes the hard thing to get, is that R plus 50. Okay? Now that I have that, I can typically figure out the rest. I am going to use this distance equals rate times time. Okay? I've got my distance. So my plane that's traveling westbound For 3 hours, it travels at some rate. We don't know what that rate is, but it travels at some rate. My plane that is going eastbound, it also travels for 3 hours, and its rate is r plus 50. Now, if I take this distance right here, 3 times r, and I add it to this distance right here, 3 times r plus 50, what do I get? What does it equal?
2,200.
Correct. It does. Okay? So the distance that my westbound train travels, which is 3r, plus the distance that my eastbound train travels, which is 3 times r plus 50, equals 2,250 miles. So now I have my formula. And that's the hard part. The hard part is getting that relationship together, and that takes practice. And that's why on the quizzes I give you this, on the practice test I give you this, on the classwork we did today I give you some more problems. Okay? So now I've got my formula. Can I rewrite my formula on the next screen? Can I move off this screen? Okay. Make sure I write it down right. I have 3r plus 3 times r plus 50 equals 2,250. Now I solve. Now I'm going to solve. 3r. Now I've got to distribute this 3. So I have 3r plus 150 equals 2,250. So I have 6r plus 150 okay. I subtract 150 from both sides. Nope, that's not right. What is it?
100.
Good, 2,100. Okay. Now I'm going to divide both sides by 6. Okay, so I have 2,100 inside the box, and I have 6 outside the box. Okay? 6 does not go into 2. So I put my little X up there. 6. How many times does 6 go into 21? 3 times. 3 times 6 is 18. 21 minus 18 is 3. So I bring down my 0. How many times does 6 go into 30?
5.
Good. 5 times 6 is 30. I subtract, then I've got another 0 that I bring down. 6 goes into 0 0 times. So the rate of one of my planes is 350 miles per hour. That was my westbound. My westbound plane travels 350 miles per hour. Okay? What does my eastbound plane travel? Say that again.
50 miles faster.
Good. And what's 50 miles faster than 350? 400 miles per hour. Okay? So that are the speeds of my 2 planes or trains, depending on what we're talking about. Okay?